Hi, everyone. Welcome to this session where we're going to be talking about building serverless and modern applications using Amazon S3 or EFS. My name is Higgy Park. I am a principal solutions architect here at AWS, and I focus on serverless capabilities and building cloud native.
Hi, my name is Eric Bowman. I'm a senior solutions architect specializing in the storage space, and I work with EFS and S3.
All right, in today's talk, we're going to talk about serverless and what it is and why you as a customer should really care about serverless. And so, when I talk to customers and when they're thinking about building cloud native applications or when they're just thinking about building on AWS in general, really, these are the four categories where we try to focus with our customers. The first is around agility. As your customers are thinking about how do we build features and capabilities that drive our business forward, we want to do this as quickly, efficiently, but also safely with security in mind. So this agility aspect helps you think about prototyping and building capabilities into your business as quickly as possible. And we'll talk about examples of that in a little bit. The other one is around performance. So this is the ability to meet customer demand, meet customer requests, and scale based on customer usage and do that quickly and responsively. And then the third one is around cost, right? The ability to say, I don't want to have large amounts of idle compute waiting for incoming requests, but rather I want to pay for the compute that I use and the amount of compute that I need as that compute is happening. And so this helps you to have a better TCO for those applications. And of course, then the last one would be around security. Again, here at AWS, security is our top priority. And we want to ensure that when you're running your applications, you do so on a platform and in a mechanism that allows you to do it that is both secure and isolated from other workloads. So when we think about some of our customers who are actually building with serverless, these are four kind of general categories. We've seen some of our customers doing it. A lot of times customers will start with IT automation, right? The idea is you're running in your AWS accounts and you have a number of things you want to do around governance, around controls, around configuration management, and you can use serverless capabilities to be able to do this. Another is around data processing, right? And data processing is a pretty encompassing idea, but there are things like I have large amounts of data coming in and I want to maybe do some ETL. I want to maybe extract some data, or maybe I want to get real-time insight on streaming data, right? So there's lots of opportunity to see how do we use some of these serverless capabilities to ingest and process that data, whether it be batch-oriented or in near real-time. Another would be around web applications, right? Maybe you have front-end mobile applications or you have web consoles or dashboards that your users are using. This could be external or internal users. And you may have things like REST APIs or GraphQL APIs. And this allows your customers to then interact with some type of backend system that you're exposing. And so again, you can use serverless technologies to be able to build these type of interactive web applications out. And then the last one would be around machine learning. Again, machine learning is a pretty expansive field. So there are things that you could do like ingestion of data to prepare data modeling. Maybe you can do small amounts of training. Again, we've seen some customers do things like AutoML for selection of models. And also you could do things like using those models for doing inference, right? So you can maybe have a serverless application that can select an inference model that you would then use to, again, validate or infer against incoming data sets. So what is it that we mean when we think about serverless? So serverless is more than just compute. So, 5, 6, maybe 7 years ago at this point when Lambda was introduced, again, there was this idea of a function as a service. And again, there's lots we can talk about from a serverless standpoint. Here at AWS, there are really two compute platforms that we want to think about from a serverless standpoint. The first would be Lambda, which would be our serverless functions. And then we have also AWS Fargate, which would be your serverless container. Now, as you see on the slide here, there's also two other categories we can talk about. One will be around data stores, which Eric will get into in a little bit. And this, again, is Amazon S3 for your serverless object store, EFS for your file systems, and then DynamoDB for your NoSQL stores. And then the third category here is around integrations, right? And so the idea here is as you're building your applications, again, maybe you're deploying it in Lambda, maybe you're deploying it in Fargate, you want to integrate this in a broader ecosystem. So again, some of these examples are with Amazon API Gateway, you can construct and build REST APIs with a serverless compute backend. AppSync would be for building GraphQL APIs. SQS, or simple queue service, would be around building a serverless queuing mechanism. So this is where you want to decouple applications from each other, and you can use SQS for doing that. SNS, our simple notification service, there's actually two modes for this. One is if you want to actually do end user notifications, right? So this would be our application to user integration. This could be things like mobile push notifications, SMS messages, or even emails. And then the second mode would be around application to application, right? So I actually want to connect, or I want to fan out my messages, so I could actually have an SNS topic with multiple different Lambda functions subscribing to that, and each of those can be processing those messages differently. The next one would be step functions. You can think of this just around workflow orchestration. I have a set of business processes that I want to do. Maybe some of this is serialized. Maybe you want if-else type logic. Maybe you want to parallelize things. Step functions you can think of as I have a state machine. I want to orchestrate my workflow, and I'm going to use step functions to manage that workflow. And then the last one is event bridge. The simplest way to think about this is I just want to route my events to different downstream targets. And I want to have a decoupling between those message producers and the message consumers. So I have a message producer like a mobile application, maybe a web front end. I'm just going to send it into an event bridge bus, and we can allow event bridge to then configure a set of rules or routes to then send it down to the downstream target. So what we're going to do is I'll just talk briefly about Lambda and storage options for Lambda, and then Eric is going to dive a little bit deeper into our storage options. So with Lambda, there's kind of two ways to think about it. One is local storage, right? So with AWS Lambda, when you deploy your function, you can deploy it with a 10 gig package, or sorry, a 10 gig or a 250 meg package. So there's one is you can zip it up or have a Java jar artifact, and that would be this deployment package of less than 250 megabytes, or you can actually use a container image, and that would be up to 10 gig. Then within the function, what we call the execution environment, so this is the operating environment of your function code, you have up to 10 gigs of memory, or you also have temp space. So this is the one area within your function where you're allowed read-write storage. This would be /temp. By default, it's a half a gig, 512 megabytes. But you can also configure it all the way up to 10 gigabytes. The second option is around external storage. So in addition to those options that we had just talked about, you can also configure your function. Again, you would have to configure appropriate IAM roles. So your execution role would need access to write to, let's say, a particular S3 bucket. Or you can attach an EFS file system using an access point and then use that as read-write storage. So Eric is actually going to go into a little bit deeper on this. And so I'll turn it over to Eric.
All right. Thanks, Higgy. Okay. So first, let's take a look at why S3 and EFS are great storage options for serverless applications. Since these storage services are designed from the ground up to be cloud-native storage solutions, they both offer seamless integration with other AWS services. So first, we have identity and access management, or IAM, allowing for a consistent approach to granting users and services access to storage resources. Then we have AWS Key Management Service, or KMS, offering a centralized management of data encryption keys. This allows for full control over access to encryption keys and key rotations of customer managed keys, providing peace of mind that data is securely encrypted at rest. Next, both services are integrated with AWS Backup, providing a centralized single pane of glass for data protection engineers to manage and validate their organization-wide backup strategies. Both services also offer native replication services, including cross-region support, protecting against localized outages. And finally, and potentially most importantly, these storage services are both natively supported by the comprehensive suite of AWS compute services. So we'll talk a lot about AWS Lambda in our discussion today, but container services such as AWS Fargate, Amazon Elastic Container Services, or ECS, and Elastic Kubernetes Services, or EKS, as well as Amazon Elastic Cloud Compute, or EC2 services, are all offer native integration with S3 and EFS storage services. Amazon Elastic File Service, or EFS, is a fully managed, serverless, elastic, shared file system designed to be consumed by other AWS services. EFS is a petabyte scale file service offering that does not require you to provision capacity, and you only pay for what you use. EFS is highly available, designed for 11 nines of data durability. EFS offers 4 storage classes, 2 multi-availability zone storage classes, including Amazon EFS Standard and Amazon EFS Standard Infrequent Access, and 2 single availability zone storage classes, including Amazon EFS One Zone and Amazon EFS One Zone Infrequent Access. This allows customers to choose the most cost-effective option based on the needs of each workload. EFS offers sub-millisecond latency for files stored in the standard classes and double millisecond latencies for files stored in the infrequent access classes. EFS file systems support gigabytes of throughput, hundreds of thousands of IOPS, and tens of thousands of connections. When we think about combining EFS storage with Lambda, we now have a fully serverless solution, including both compute and storage, that can be scaled elastically and independent of each other. Developers can reference EFS storage directly inside their Lambda function definitions, allowing them to focus on the storage needs of their application instead of the infrastructure needed to support them. EFS simplifies building and importing large code libraries directly into Lambda functions, and because the storage is persistent, it ensures that updates to these libraries will be used for every new invocation of the Lambda function. EFS allows Lambda to read large reference data files without copying them to local storage, as well as write function output to a persistent and shared data store, enabling stateful applications. Okay, so let's double click on Amazon S3. So what is S3? Amazon S3 is an object storage service. Object storage is different from file storage in that it designates each piece of data as an object. Objects are written to stores called buckets, as opposed to files and folders in a traditional file system. Data is bundled with associated metadata and assigned a unique identifier. By contrast, file systems store data as files and organize them in a hierarchical file structure, and the operating system tracks file metadata independently. S3 is designed to scale elastically. Today, S3 supports exabytes of data and serves millions of customers. With S3, you do not need to forecast your data storage needs or provision capacity. You simply create an S3 bucket and it scales elastically to support your workload. S3 is also highly durable. It is designed to provide 11 nines of data durability. This means that if you stored 10,000 objects in S3, on average, you might expect to lose a single object every 10 million years. S3 also supports versioning, which offers protection against unintended or malicious activity that could otherwise result in loss of data. When a user or application writes data to a bucket and uses a unique identifier that has already been written to that bucket, the new data becomes the current version. The original data, however, is still retained and is moved down the version stack, becoming a previous version. This allows for retrieval of the original data if necessary. Lifecycle rules can be configured to expire or remove previous versions of data after a defined period of time to help reduce overall storage consumption. S3 offers several storage class options to choose from. Each storage class is designed to offer cost-effective options to store data based on the access patterns and data retention profiles of your workloads. Lifecycle policies are offered as a tool that can be leveraged to automate the transition of your data to more cost-effective storage classes as your data ages. If you are unsure as to how data access patterns change over time for your workloads, S3 offers the Intelligent Tiering Storage class, which monitors the activity of your data on an object by object basis and transitions objects to the appropriate access tier based on activity instead of time sense creation. And finally, S3 is natively integrated with Lambda as an event source. This means that S3 events, such as the put of an object to a bucket, can be used to trigger Lambda functions. To do this, we use S3 event notifications. S3 event notifications offer a reliable and scalable notification solution for S3 activities, such as the creation or deletion of objects, restoring objects from Glacier Flexible Retrieval or Glacier Deep Archive, or replication and lifecycle activities. Multiple delivery destinations are available, including a simple queue service or SQS for decoupling from the workflow, notifications via the simple notification service or an SNS, and serverless code execution via AWS Lambda. S3 event notifications are designed to be delivered for low latency and at least once. The event notifications themselves are also absolutely free to use. Usage charges for the chosen destination services will be incurred when applicable. S3 event notifications work great for simple event-driven workflows, but if your workflows are more complex, S3 event notifications may not offer the flexibility you need. For these instances, you can leverage S3 event notification integration with Amazon Event Bridge. Amazon Event Bridge is a serverless event bus that lets you receive, filter, transform, route, and deliver events. It's fully integrated with S3 events via CloudTrail. With Event Bridge, a single event can trigger multiple workflows, or multiple events could trigger a single workflow. Event Bridge uses industry-leading pattern matching, allowing you to filter your events by prefix, suffix, or any other piece of contextual information from the event, such as IP address, IAM user, or creation date of the object. And with its guaranteed delivery, you can count on every event being triggered for every operation. So we talked about event-driven architectures leveraging S3 notifications and Event Bridge. In both of these cases, the client that actually performs the action, such as putting an object to an S3 bucket, is not aware of the workflow that's been triggered by the event it created. There could be additional steps in the workflow that provide feedback to the application, but the actual S3 action, the put of the object to a bucket, provides no additional feedback to the application or end user. For this, we can leverage S3 Object Lambda. S3 Object Lambda lets you add your own code to be executed in line with the S3 get, head, or list operations. This allows for processing or enrichment of data before S3 responds to the request from the application. The distinct advantage here of Object Lambda over other serverless event-driven architectures is that you can modify the real-time response to the get, head, and list API calls. This allows S3 to return a unique response to these calls based on the context of the request, like the IAM role of the requester, and there's no need to modify the existing end-user application. Since the launch of S3 Object Lambda, customers have found several opportunities to use it for simplifying workflows. Some examples include decompressing archived files stored in S3 on the fly as an end user is retrieving them, transcoding video or resizing images based on the capabilities of the device requesting the data, or even adding watermarks to content based on the access level of an authenticated user requesting an image. Or in shared data set environments, customers have the need to return filtered subsets of objects depending on which authenticated user submits a list request against a bucket. This ensures that users only see the data that they're authorized to access. Object Lambda also has been used to help customers with requirements around limiting access to personally identifiable information or PII data. For example, customers that have, say, maybe different personas within their organization that need to reference the same documents, which include PII data. It's possible that maybe one persona, perhaps a billing team member, may need to see details such as the account number or credit card information, but they don't have any business need to see information such as maybe the customer's email address or a support PIN number. And then maybe there's a second persona within the organization, maybe somebody who is on the support team who needs access to see email addresses and support PIN numbers for verification purposes, but they have no business need to see things like credit card or social security information. In the past, customers have stored iterative copies of the same data with the appropriate subset of data redacted for each persona. This not only increases the storage consumed to retain multiple copies of the same data, but also increases the complexity of the data ingestion workflow and overall data management. With Object Lambda, we can store one copy of the original data set and invoke a Lambda leveraging AWS Comprehend services to identify and redact the appropriate PII data on the fly based on the IAM role of the requester, all completely transparent to the end user experience. Okay, so Event Bridge and Object Lambda are powerful ways to initiate serverless workflows with S3. But what if you need to take action on a large set of objects already stored in S3? For this, we have S3 batch operations. With batch operations, you can specify a dataset using a manifest file, including the bucket, name, and the key value information for each of the objects you want to take action on. This manifest file can be generated by enabling S3 inventory reports for your buckets or prefixes, or it can be generated manually. Batch operations jobs can then be created with a defined function and outcome and will iterate through each object listed in the manifest file. Batch operations has several canned functions such as copy object and glacier restore that help you manage your S3 data at scale, but additionally, it can serve as a trigger to run custom Lambda functions. Batch operations is a managed offering with error and retry handling, as well as progress and completion reporting. Batch operations is designed to support multiple parallel jobs and can be used to manage data sets with hundreds of millions or even billions of objects. Okay, and now I will hand it back over to Hegi to discuss some serverless use cases.
Cool, thanks, Eric. So what we'll do is we've learned a lot about both Lambda and S3 and EFS and a number of these integration options. What we'll do here is we'll go through and show some examples of how you as a customer can actually use some of these capabilities. So Eric had talked about this a little bit, but here's another example where I have an S3 bucket, and maybe I upload a picture to that S3 bucket. Maybe I have some mobile or web client where those images will land into that S3 bucket. What we can then do is we can then trigger a Lambda function directly on each object put action or event, and then run some custom logic, right? So this would be, and what would happen is within the Lambda function, it would get an event payload, which essentially will tell it, among other things, at least the object key along with the bucket name. Now, the nice thing with kind of this decoupled way of building serverless applications is you can begin to extend upon these capabilities. So for example, you've done this, you've gotten some extraction, and now beyond that, maybe you want to do things like use our Amazon recognition service, where you can send that photo to that service. It will then extract a certain amount of metadata. So you can maybe say, is there a cat in this image? Or is there another vehicle, maybe a car or a bus in this image? You could extract that metadata, return it back to your Lambda function. And maybe now I also want to store that. So maybe I'll store that in a DynamoDB table. And maybe I have some other downstream applications that will go and read this table and conduct some sort of analysis, or maybe alert if some type of business event actually happens. Another example might be, let's say I have a mobile application, right? And as a business serving my consumers, I want to understand, what does the consumer experience look like? So maybe my mobile application is going to stream user experience information, right? So when they're opening up certain screens, maybe when they initially open the mobile application, maybe how long it takes to open the application, or maybe how long it takes to take certain actions. So your mobile application can then emit telemetry data into Amazon Kinesis, specifically the Kinesis data streams portion of Kinesis. And this is essentially a service that allows you to create streams, and you can then ingest all of that telemetry or IoT type data. From Kinesis, you can then trigger a Lambda function. So that number one, where you have the Lambda service, will act as the poller. So one nice thing about this pattern here is, normally without Lambda and the integration with Kinesis, you, as part of your application, would need to write that consumer logic, right? So you're going to have to poll for the records that are coming out of Kinesis, and you'll have to actually commit certain offsets where you are in stream processing. The nice thing here is this number one is that the Lambda service handles all of that polling on your behalf, along with committing offsets after you've completed processing. So Lambda service will actually act as the consumer to Kinesis. It will read those records based on your configurations, and it will then invoke a function synchronously with a batch of messages, again, how you've configured it. Then, of course, as we've been talking, your Lambda function will go and do some amount of processing. Maybe in this case, you're going to send data down to Redshift as part of your data warehouse. And maybe you'll also send some of that data down to S3, maybe in Parquet format, because you're now creating your data lake. Maybe your data scientists will go in later and do some analytics or maybe do some machine learning training based on the data you've written into S3. So kind of extending on the idea of machine learning, you can also then, after perhaps your data scientists have trained a model, you can then take those models and put those onto EFS. Now your business application will invoke Lambda, and Lambda, again, in this case, mounted that EFS file system. It has a model on there. Maybe it has some additional libraries that your application needs, things like TensorFlow or PyTorch, maybe some C++ libraries. Those will all reside in EFS. Your Lambda function, when it gets invoked on that initial startup, it will actually read in the models into memory. It'll load up all the appropriate libraries. And then now you'll actually do the inference. So here you can actually use this to do inference. And maybe you were trying to do fraud detection based on whatever your use case was. So each time that event comes in, it checks and sees, was there fraud in whatever this transaction may have been? So here's now an example where Lambda serves as the compute layer using EFS for the underlying storage. Another example might be you have a call center. You have a large customer support base. And maybe you want to get some additional information or analytics out of your call center. So again, I've been on support calls where, I'll hear a recording or someone saying, these recordings will be stored or recorded for quality assurance and training purposes. Well, in this case, maybe you have call center reps who the recordings get written down to S3. Maybe we trigger a Lambda function, which will then go and read that maybe that MP3 file that was written down to S3. And maybe in this case, we're going to send it out to transcribe. So now we want to convert the audio recording into text. So we can use Amazon Transcribe to be able to convert that into text. What we'll then do is our Lambda function will then write it down subsequently to an S3 bucket. Now we can kind of do this again, where when we write the text into S3, we trigger another Lambda function. And in this case, now we talk to Amazon Comprehend, which is a service that can do things like sentiment analysis. Right. So maybe what we want to do is we want to look at the audio transcript of customer support. Maybe we correlate that with a product ID that the customer was just calling about, and we kind of get a sentiment score. Maybe the customer is neither upset or happy, but they're just asking a question, or maybe a customer is extremely upset. Then you could store all of that data into DynamoDB, and maybe you have some business analysts come in afterwards and say, is there a correlation between the increase in perhaps extremely negative sentiment calls, and maybe there was a certain product change? So you can kind of look at line graphs and see at a period of time where there was a larger volume of negative sentiment calls. And maybe you can go and do some additional analysis to determine, was there a defect in the product, or maybe something had changed. And maybe then you as a business can then respond to that and perhaps correct some of the negative sentiment for a particular product. And the last example I'll go over is, this is actually a customer reference. So here Ryanair had a mobile application. And again, in the height of the pandemic, they were trying to validate and ensure that their travelers either had a recent PCR negative test or a COVID vaccination. And so part of their mobile application, what they would do is, in order to upload the verification information, the app would then make a request API gateway. Again, this would be a REST API. It would trigger a Lambda function, and it would then return an S3 pre-signed URL. Essentially, this is just a simple way for the mobile application to be able to upload those PDF documents. Now, what they wanted to then do is they wanted to display the verification information inside of the mobile app. Now, they didn't want to render the PDF document. They wanted to render an image. So what they could have done was they could have taken the PDF doc and then triggered a Lambda function to then generate an image and store that. But as Eric had mentioned, this incurs additional storage cost, and they figure, why don't we just do this inline? So like Eric had talked about before, they use an S3 object Lambda, which then converts the PDF into, let's say, a PNG file and returns that through the S3 access point. And now the mobile application can then render the image file. Right, so this allows them to be able to do that inline, as Eric had mentioned before, without having to store that image. Or alternatively, they could actually cache that in case the mobile application would expect to actually return that same image multiple times. So you have the option of either doing it inline or actually rewriting it down to S3. But in this case, you can do it inline. So hopefully the number of use cases that we just went through is helpful in illustrating the art of the possible, the different things that you can do with some of these serverless capabilities and with these storage options as you look to build your applications and hopefully meet the demands of your customers. And so with that, Eric and I wanted to thank you for your time, and we hope that you were able to learn and now apply these learnings to your business use cases. Thank you very much.